you are. ठीक
Yes,
है?
sir.
So you can do much better. ठीक है?
Yes.
So yeah, so let's do some numerical. Just allow me a moment. So how much in the maths, Zainab?
So for me,
Yeah,
uh, 33, sir.
33 out of 80.
Yes, sir.
Why so low?
Like this time, fully I got confused on the paper.
It means that you have a little bit confusion in the topics.
Not confusion, sir. I started getting scared. I forgot what to do. I
Okay.
knew everything. After I came
Mm-hmm.
home, I wrote everything. I checked the answers.
Mm-hmm.
Everything was right. But in exam, what was supposed to be written, I wrote it ulta.
Oh, okay. Okay. You just got scared and confused. Okay.
Yes, sir, because at the end, I had only half an hour and most of my marks, like 20 marks and 10 marks and 12 marks were left.
So you can do one thing. Try to solve the numericals as much as possible. Okay.
Yes, sir.
Yeah. Just allow me a moment. I am basically pasting some MCQ questions of NCRT exemplar.
Yes.
Yes, Anam. So these are the questions basically. So these are the MCQs. So just a moment. अरे यार जस्ट टीयर्स मुझे कट करना होगा क्योंकि ये गलत पीडीएफ आ गई आपके पास. सो दोबारा से प्रैक्टिस रिवीजन स्टार्ट कर दिया आपने? Zainab,
Um, yes, sir.
I'm asking that have you started the practice again?
Yes, sir. These 2 days I couldn't practice because I'm sick, sir.
Okay, okay. Yeah. Yes, Zainab. So please attempt the questions one by one and let me know the correct answer because these are the NCRT exemplar questions, and they are like there are very high chances that MCQs can be from the exemplar from in the boards, right?
Yes, sir. Sir, can you
Yes.
zoom it a bit? My laptop's vocal is down.
Your laptop?
Can you zoom it a bit,
Okay,
sir?
okay, okay, okay.
The focal is down.
Just
Yes, sir. Fine.
is it fine now?
Yes, sir.
Yeah. Do the first one.
Sir, is it C?
So the magnet, we have to identify which one is incorrect.
Yes, sir.
Yeah. So the direction of magnetic field line at a point is taken in the direction in which the, just a second. Yeah. So in which the north pole of a magnet compass needle points,
Yes,
magnetic field lines are closed curves. If magnetic field lines are parallel, then they represent zero field strength. Relative strength of magnetic field is shown by the degree of the closed field lines. So
sir.
you which point, basically which option you said?
C, sir.
Okay, see. Let's analyze the question the answers one by one.
Yes, sir.
So basically, you can see this thing, that direction of a magnetic field. Basically, the compass needle shows the north pole of the compass shows that the direction of magnetic field. Yes or no?
Yes, sir.
Okay. So just a second. So this can be this is a correct option. Next is
Yes,
magnetic field lines are closed curves. Yes, we know that magnetic field lines are closed curves. So
sir.
that is also a correct part. If magnetic field lines are parallel and equidistant, they represent zero field strength. Is it
No,
true?
sir. No.
No, because they represent the uniform magnetic field line.
Yes, sir.
Uniform magnetic field. So C is the correct option. Very good. Second one, if the key arrangement is taken and the magnetic field lines are drawn over the horizontal plane of ABCD, the lines are, what
The
will be
one
the
minute.
types of lines?
1 minute, sir.
Yeah. Think try to recall the basically the shapes of a conductor.
Yes, sir.
Yeah.
Sir, is it D, concentric circle near the point O, but of elliptical shapes as we go away from it?
As the basically you said D, concentric circles near the point O,
Yes,
but
sir.
elliptical shapes as we go away. Is it true? Sure.
Sir, I have a confusion that it is C or D.
Okay, so think a little bit. Giving you one more minute. Okay, see this one thing. The question is saying that the key is circuit is made open. So basically, no current will flow because the circuit is open. So we have to identify. So basically, only the earth magnetic field will be there. Yes or no?
Yes, sir.
So if the earth magnetic field is there, so the magnetic field of earth is basically straight in nature, straight lines
Yes,
and
sir.
parallel to each other. Clear? So C1 is the correct one.
Yes, sir.
Clear? Concentric will be,
Towards the field.
yeah. So let's do the third one. A circular loop is present in a perpendicular shape to the plane of a paper and carries a current, and the key is on. Basically, key आपकी on है, circuit is closed. It means that the current will produce the magnetic field.
Yes,
So the current as seen from point A and B is anti-clockwise and clockwise respectively. यानी कि at point A, the current is anti-clockwise, but at point B it is clockwise. Clear?
clockwise.
Yeah.
Yes.
So magnetic field lines from B to A. So the north pole of the magnetic field lines from B to A. The north pole of the resultant magnet is on the face close to. Think a little bit of this question and let me know the correct option.
Yes, sir. Plane. And sir, is it B if the current is small and A if the current is large? D option.
Option D, according
Yeah.
to you. Okay.
Sir, it's 1 minute.
Okay, think a little bit again.
Sir, it's B, sir. Option B, not D.
Option B. B, okay, B for B.
Yes, sir.
You are close, but the correct option is A, dear. The North Pole. When the current is anti-clockwise, basically the you can say up when the current is anti-clockwise, so direction of the pole, basically the that circular coil behaves like a North Pole. Yes or no?
Yes, sir.
So it would be towards A.
Yes, sir.
Yes or no?
Yes, sir.
Got it. So if the question says the North Pole of the resultant magnet, basically if the question says South Pole, sorry, if it says South Pole, so that would be B. Clear?
Yes, sir.
Okay, do this one. For a current carrying conduct, the long straight solenoid N and S are created at two ends. Among the following statement, the incorrect is.
Sir, it's option C.
It's option C. Very good. Because the pattern is very magnet. Clear?
Yes. Yes, sir.
Second, fifth one.
Sir, is it force pointing out of the plane of the
So
paper?
let's understand. Let's understand. Basically, the question is saying that an uniform magnetic field exists in the plane of a paper, pointing from left to right. Okay. In the field, an electron and a proton, as shown, as basically moves as shown. The electron and proton experience both forces. No. Okay. Proton upwards,
An electron is
downward.
down.
Hmm. Out of the paper and into the paper. No. Out of the paper वाला नहीं होगा, ये होगा using right hand thumb to diffuse. See this thing. So see this thing. Which option you said, Zainab?
B, sir.
B,
Yes, sir.
out of the plane.
Yes, sir.
No, that would not be correct. Listen, one thing. So if the electron is flowing in the downward direction, in which direction the current will flow? In the
Upward.
electricity upwards, na? So it means
Yes, sir.
that the current of this basically electron stream is in the upward direction, and proton is already positive. It means that current will already flow in the upward direction.
Yes, sir.
So if the proton is in the upward direction, we asking about the current.
Yes, sir.
Fleming left hand rule talks about the current, not the sign of the proton or neutron electron.
So
So if the
Fleming.
current in both the cases are upwards, so see this thing, take the
Yes.
fingers.
Yes, sir.
Your middle finger shows the uniform magnetic field, and the basically the upward,
Mhm.
yeah, this the thumb shows the upward motion, and the
Mhm.
forefinger is going inside into the plane.
Yes, sir.
Clear?
Yes, sir.
So try to be a little bit more analytical while solving these kinds of questions. They looks very simple. You can see that they are looking very simple, like, yeah, we are able to solve. But sometimes these questions involve so much concepts in very depth. Clear?
So I have a doubt that
Uh,
I was writing the test series, or
mm-hmm.
I guess it is magnetic field of current, that test time. They asked to find the motion. Motion means it is right hand thumb rule. Then I cutted it and I wrote it as Fleming's left hand rule. So
If they
Fleming's
are
left
asking
hand.
about the motion, then yeah, it means that it's talking about the force, and the force is in the which concept, Fleming's left hand rule. Clear?
So for
Uh,
finding the direction of current only, right hand thumb rule, right?
for finding the direction of not current, direction of magnetic field.
Yes, sir.
Clear?
Yes, sir.
So basically this you can skip this part because it's already omitted. Commercial electric motors. See,
Yes.
electric motors where all the things are omitted, so you can skip this thing. So it is written, something is written here that there are two coils around a non-conducting circular cord, cylindrical cord. Initially, the key is not inserted, then the key is inserted and later removed. Then the deflection of the galvanometer remain zero throughout. There is momentary deflection, but it dies as shortly. There is no effect in. So think basically galvanometer is a kind of device which you can say is used in the electric with the electronics. You can say I'm not able to recall the basically proper use of galvanometer. It's a long time to read basically. So galvanometer is a kind of, see this thing, that galvanometer can be used to convert, can be used to make the voltmeter as well as the ammeter. It's a kind of device. I'm not able to recall the proper its exact use of that. So basically see this thing.
The galvanometer, I remember in school, my teacher said that it is an instrument for measuring the electric current as well as the
As
potential.
potential, yes, I was saying that it is also used to make the voltmeter as well as the ammeter.
Yes, sir.
Yeah.
And they have direction and magnitude of current, right?
Oh, not the direction, dear. It tells you about the magnitude only. This meter. Okay.
Yes, sir.
Okay. So see this thing that in this arrangement, there are two coils. So two coils are already wounded. Okay, around a non-cylindrical conducting cylindrical rod. So initially the key was inserted. Okay. Key is not inserted, but after some time you have inserted the key and later you have removed this. So basically you have passed the current, completed the circuit, so current will flow.
Yes, sir.
And when you basically remove the key, what will happen? Yes,
The
Anna?
current will deflect.
No, current will flow or not when you open the key?
Yes, sir. It will.
It
No,
will
it won't.
it will
It
flow.
won't. No, no,
It
it
won't.
won't.
Huh? So basically what would happen is that, okay, so where is it? Yeah, this is the question. So basically, it is a kind of so when you open the when you complete the circuit, the current will flow. But when you will open the circuit, the current will stop flowing, and the deflection, momentary deflection will be there. Suddenly, like galvanometer shows a very high deflection suddenly, but when you open the circuit, it does not show that much deflection, and it if and after removing the basically key, the galvanometer, the momentary deflection of the galvanometer dies after some time. So, but if the current is flowing in the direction in the right direction, so galvanometer will show the deflection in the left direction. Clear?
Yes,
So
sir.
it is say, so which option is there? So there is a momentary deflection, but but it dies shortly, and there is no effect when the key is removed. No, no, this is not correct because galvanometer have the effect if the key is removed. There are momentary galvanometer that die out shorter, the deflection are in the same direction. No. So D option is the correct option. Clear as Zainab?
Yes, sir.
Okay. Let's talk about this eighth question. Tell me. Fleming left hand, right hand rule is known to the direction of induced current. A thumb rule, correct information.
So it is A.
It is
It
A,
is
just the final direction of due to
Fleming's
current carrying
left-hand rule is
conductor.
used to find the force, right?
Just a second here. The direction with difference between the direct current and is that flows in but various alternate current in India the AC is every 50 second. Yes, dear, it's A because all the parts are correct because in India the basically the frequency is 1 by 50 and I've told you that difference between direct current and alternating current is that direct current always flow in one direction but alternating current reverts its direction periodically. I've made a graph for that the starting in this
Yes,
portion. You must have remembered that thing. I
yes,
think yeah, here it is. You can see now once after in a one cycle it is positive, in the second cycle negative, then positive. Clear?
yes, sir.
Yeah, very good. So a constant current flows in the horizontal plane from east to west. So the current flows from east to west. So this is the flow of current. Clear? The direction of magnetic field will be at a point will be north to south. The direct will be north to south. So we have to find out the, just a
The
second.
direction of
Basically,
magnetic field.
constant current. So current is in this direction. The direction of magnetic field at a point will be north to south. Okay. So it is already given the direction. So it's asking about the motion. So basically, take your finger in the, so it is north to south. So north to south. So magnetic field is in the direction of north to south. Okay, but the current, it will develop at a point on the in the plane of the paper, the located in the plane of the paper on the south side of the wire. So देखो ये आपकी इसे गई, ये आपकी current is the middle finger now. So I think it's just a second, directly below the wire. No, directly below will not be the correct option. Current is in the east to west direction. Which option you said, Zainab?
Sir, I said at a point located in the plane of a paper on the north side of the wire.
You said the option
C.
D, C, the C option you said. Just a second, let's analyze this a little bit more because these types of question have much depth analysis. So the plane of the paper on the north side. Hmm. So it's asking about the in this question, the force is not written, only the magnetic field and the current is written. It means that it is asking about the right hand thumb rule because it must have basically right like the previous one. Where was the question? Like the previous one, it will be saying that forces, but it doesn't say anything about the force. It means that only the current and the magnetic field is involved. It means that we are asked to about the direction of magnetic field. So do you know the right hand thumb rule? Remember? So basically your current direction is shown by the thumb. So
Yes,
current is
sir.
in the direction of east to west. So it will be in left, and the curling finger will give you the direction
Direction.
of magnetic field. So you can see when
Yes.
you curl the finger is around the south pole. Yes or no? When you are curling, yes or no? Curl your
Sir, I don't
fingers.
get it.
You don't get it. See this thing that the finger. Okay, the thumb is in the in the left direction. The thumb will show the left direction, that is current. Curl the finger. Make a fist using the fingers.
Yes, sir.
In which direction it is forming?
North.
No, it is not forming in north. It is going downwards now from the straight wire. It's going downwards when you are making a fist.
So I don't get it properly. Like,
When you are closing your hand and the curling your finger, the fingers are going towards the south direction, yes or no, when you are curling it.
yes, sir.
So it means that the direction is shown by the curling of finger.
Yes, sir.
So ultimately, at which direction it is showing?
South direction.
South direction. So it will be below the wire. Clear? Ninth of B. Clear, Zainab?
Yes, sir.
Any doubt?
No, sir.
Okay, that's great. Let's talk about the next one. The strength of magnetic field is inside a long current carrying straight solenoid is, tell me, is the correct option.
More at the end than at the center. A.
You said A. Okay, the inside. It's talking about their inside, not the outside
So,
part. So it is
so
same at
it
all
is center.
points. Clear? That's why I said please try to basically be more specific. This is not in your syllabus. The most important safety method used for protecting home appliance from short circuiting or overloading is
Use
with
of fuse.
use of fuse. You said okay.
Sir,
Think
and
a little.
also earthing.
The most important one.
Earthing.
Sure. To
Sir,
protect
it's
from the
easy.
it's
A.
okay. You said A. So it's asking
Yes,
about
sir.
the safety method used to protecting from home short circuiting or overloading. So dear, if you have to prevent the short circuiting or overloading, you will be first do what? You will be first using a good kind of fuse. Earthing is the secondary part, dear. When you have used a good circuit, it's asking about the initial, first important. Clear?
Yes, yes, sir.
I there was a now you can see that there are so like options are very similar in every question.
Yes, sir.
Clear? Got it?
Yes, sir.
That's great. I hope you got my point.
Yes, sir.
Just a moment. Let me take some questions based. Just a moment. I'm taking one question. So here is one subjective question. You have to think a little bit and let me answer the question properly.
So I got the answer.
Yes, Zainab, tell me the answer.
The strength of the magnetic field would
Hmm.
decrease at the end of the solenoid.
No, it's asking what does the divergence. It's asking about the meaning. Why there is a divergence? Why basically they're spreading out.
So that's what I meant, like their field strength would decrease
Strength would decrease. Uh, you are close, but not very accurate.
because they are closed curves.
No, basically what happened, basically in the divergence near the ends shows that basically at the proper end, the magnetic field is very strong at the ending point. But when you move away, the magnetic field gets weakened. That's why it's getting diverged. Clear? You have to tell the proper reason here, okay? You are missing one point, that was that its electric field is basically strongest near the ends of the solenoid because at the end of the solenoid means at this point it will be strongest because it's almost at the inside or at the border
Yes, sir.
boundary. But after that, the electric field gets diverged. Why? Because of the less, you can say the less
Electric.
magnitude of the magnetic field. Clear?
Yes, sir.
Got it? So these are the questions. Two marker questions can be there from the boards as well. Let me write down the proper answer. The divergence, magnetic field lines near the end of a current carrying conductor. Current carrying straight conductor. Straight solenoid is strong, indicates that the magnetic. So, do you have any doubt here in the light chapter and the human eye? You would like to discuss that thing as well, Zainab?
Like, this time, I don't remember. This time or last time, I got a question
Hmm.
about the twinkling effect of star. I wrote
Hmm.
each and every point from the reader, cut, copy, paste. But still, the teacher was like, the reader explanation is not enough. You have to give your point of view. And I don't know how to give the point of view about the.
A teacher doesn't want to give you the marks. The only reason is that, dear. If you are giving the proper explanation according to NCRT, nobody can cut or deduct. Even I cannot, or anybody in the CBSE. There
Yes,
is
sir.
no,
You got half marks.
there is no problem. You can say there isn't any marking scheme which says that you have to explain your point of view. If you are basically what written is that if you are giving the proper explanation as per the NCRT, nobody can deduct the marks.
Yes, sir. Like,
There.
the apparent position of the star is not stationary. That was the question.
Okay, got it. Because of the atmospheric refraction, the light, the light enters into the surface, it's getting refracted at each and every level. That's why it shows that the apparent height is much higher.
Yes, sir. And the Earth's position is not stationary.
So all the things are basically all the questions are related to the atmospheric refraction, and all the questions have the same explanation, almost same explanation. Don't worry,
Yes.
we'll be discuss that thing as well.
Yes, sir.
In the next class, we will be discussing that.
Yes, sir.
Okay. They just wanted to cut your marks anyhow. That's why they said this, give the very, you can say, bad reason. And that's not a good thing, if I say from my own point of view, as we move away.
Yes, sir.
First, you say that you have to write the answer according to NCERT. Then you say that you have to put your point of view as well. That doesn't seem any sense.
Yes, sir.
Okay, no issues, dear. Bad, because you don't worry that basically the question paper, basically the board's copies that will be checked will be according to a marking scheme, and in the marking scheme everything is written according to NCERT, not beyond that thing. If you are given the explanation around the expected answer and the around the concept, you will be getting the marks. If you
If
have gone, if your answer is very diverted and deviated from the actual answer, so then it can be deducted. But if the answer is oriented according to NCERT, so nobody can.
yes, sir.
Okay, don't worry.
So in the electricity chapter,
Hmm.
like I could do the straight numericals like the resistors and series, but they
Hmm.
give it in triangle form and like that
Okay.
types of questions. I couldn't find out which is in series and which is in parallel. So,
Okay. So if you have, do you have the questions in the question paper?
yes, sir. The
Okay.
file.
Okay. Do one thing. Or take all the screenshots of the question related to series and parallel, in which basically, which is in the triangular form or different kinds of form, and send it to the official number. They will just write down that, send it to Amir sir. So they will send it to me, and we will discuss that thing in the next class. Okay? Don't worry about it.
Yes, sir.
Okay. Just a moment. Okay. So giving you one more question. This. Do this one. Think a little bit. Yes, Zainab, any answer, dear?
So I have a doubt that magnetic force is directly proportional to magnetic field strength, right?
Magnetic?
Field strength.
No, magnetic force. You said magnetic force something?
Yeah, sir. It is directly proportional to field strength or inversely proportional?
Yes, it is directly proportional.
Directly proportional. Sir, the deflection, the deflection will increase if the current is increased,
Why?
because because the force is directly proportional to the field.
So basically magnitude of the field is directly proportional to the strength of electric current. If you increase the current now, it's asking about the current. Force is not mentioned, so you cannot use the force right now because you have to tell the answer according to these two parameters. So if the
So, but
magnetic field, yes, you're saying something.
but field and force are internally related, right?
Yes, internally related. So you can take the two things now, that is magnetic field and the current. It's asking how will the deflection get affected if the current is increased.
If the
If you
current is increased, magnetic field also will increase.
increase, yes, because the magnetic field is directly proportional to the current, strength of current, amount of current flowing through the conductor. Clear?
Yes, sir.
So you will answer, you will write the proper thing. Magnetic field, a magnetic compass will show the deflection.
So, if
Hmm.
like there was a question in a sample paper
Hmm.
that if all the lines intersect each other,
Hmm.
what would be the given result?
What will be the given result? So MCQ type question, tha?
No, sir, it was a 2 marks.
It was what will be the result? So result will basically give you that it will show you so many direction at a point. So it is not possible. Like the magnetic field lines cannot intersect because the tangent give you the direction, and at a point you are getting number of tangents. So that will leads to different direction, and that is not possible. Because if you are standing at a point and you are saying that you can reach your destination if you go in any of the direction, is it possible
No,
logically? No, na.
no, sir.
So same goes with this thing, that if you have the intersection point and there are number of intersection at a point, so basically because at one point, the point at which the lines are intersecting, that point will give you so many directions of the magnetic field, and it is not possible. Magnetic field can be given by only the tangent,
Right.
and but yeah, so like this
Single direction.
yeah. So if you give, basically this is the intersecting point. Suppose that this is a magnetic field and you are basically making a tangent to it. It is giving in this direction and it is giving in this direction. Is it possible to have the two direction of a single point?
No, sir.
No, na? So that will be the result. Clear? Zainab, clear?
Yes, sir.
Okay, magnetic compass will show deflection if you brought near the current carrying wire. Okay, so basically deflection, the deflection compass will increase by increasing the current in the wire. Clear, Zainab?
Yes, sir.
Okay, so and basically you will write the second point. A magnetic field directly proportional to the current flowing through the wire. Clear, Zainab?
Yes, sir.
That's clear. Any doubt?
No, sir.
Okay, that's great. So what? Why do we use right hand thumb rule?
To find the direction of magnetic field.
Field. And okay, so what does the thumb indicates in the right hand thumb rule?
So, should I state it?
Yes, yes, you can tell me.
Right hand thumb rule states that if
Basically, right hand thumb rule. In the right hand thumb rule, the direction of thumb indicates the direction of current, and the fingers curled in the direction will be given by, will give the direction of magnetic field. Clear? And how it is different from Fleming's left hand rule? So it is different by from Fleming left hand rule is that basically the right hand thumb rules give you the direction of the magnetic field, but the Fleming left hand rule gives you the direction of force experienced by the conductor. Okay?
yes, sir.
It will give you the force experienced by the conductor in a magnetic field. Any doubt?
No, sir.
Sure? Clear?
Yes, sir.
So you can see these kinds of question can be there for your school exams or boards exams. Okay? So that basically tells you about the idea. How so these are very important questions. All the questions are important because there are very high chances that these questions will be there in your school boards exam.
Yes, sir.
Okay? Just allow me a moment. Okay, so these I've given some questions for the homework as well. Okay, Zainab. So for that you can attempt those homework. They're from the exemplar book as well. Clear?
Yes, sir.
Okay, just a moment. Let me ask you one more question. So Fleming left hand rule is used for the
Direction of force.
direction of force. And what does the left hand, basically the right thumb and the forefinger and the index finger, sorry, middle finger shows in the Fleming's left hand rule?
Mutually perpendicular.
Mutually perpendicular. Direction of force is given by which finger?
By the forefinger. No. Yes, sir. By the forefinger.
Okay, direction of field,
By the middle finger.
direction of current.
By the thumb.
Wrong, dear. The forefinger will gives you the direction of field, the thumb will give you the direction of force, and the direction of current is given by the middle finger. Clear? Eh?
Sir.
Let me
Yes,
write
sir.
it down. Thumb and the force is given by, the current is given by, current की जगह लिख देते हैं magnetic field.
forefinger or index finger you can say. नेक्स्ट इज आपकी मैग्नेटिक फील्ड हो गई। अब उसके बाद आपका आता है करंट। ये दिखाता है मिडिल फिंगर और सेंटर फिंगर, मिडिल ही लिख देते हैं, मिडिल फिंगर। क्लियर है? Okay, so keep this thing in your mind क्योंकि suddenly this can be a numeric one marker or MCQ type. Which of the following shows the direction of force? Which of the following shows the direction of magnetic field? मतलब आपको just a second, let me give you कि आपको यहाँ पे Fleming left hand rule can be there। जैसे कि ये आपको फिगर दे देंगे एंड इन द फिगर समथिंग विल बी मिसिंग, मैग्नेटिक फील्ड मिसिंग है या फिर करंट मिसिंग है।